Grade 12s, we're going to look at the sine law today. It's nice to be away from angles of rotation and back to triangles and do something practical with our trig. I know that the sine law is familiar to you, but we're going to look at this triangle ABC and recall that we can't always solve these triangles by creating two right-angled triangles. For instance, I could drop a height from A down to the base and solve for the sides that way. So I could use my 40-degree triangle on the left side, label that right angled triangle with opposite, hypotenuse, and adjacent, and find my height by using SOHCAHTOA. So in the triangle on the left, I could use opposite and hypotenuse, so sine of 40 degrees equals the opposite side, which is the little h, over 15, and solve for h that way. So my height would be 15 times sine 40, which gives me an approximate height of 9.64 meters. I could use that height with the right angle triangle. I guess the order doesn't matter how we do this here. We could use that height with the right hand triangle to find the long side from A to C. So to find AC, I would use opposite, hypotenuse, adjacent. With the blue triangle to find AC, I'm going to use opposite and hypotenuse. I have my opposite side now. I found that from the other triangle is 9.64. So sine of 60 is 9.64 over the side AC. When we have the variable on the bottom, we always end up doing a division. But how we get there is we multiply both sides by AC, which leaves us with AC sine 60 equals 9.64, and then divide both sides by sine 60. So 9.64 divided by sine 60 will be our side on the right, which is about 11.13. Okay, if I'm trying to solve this triangle, I have found one of the missing sides. I know the missing angle is 80 degrees because any triangle would add up to 180 degrees in the corners, but I don't have the length of the bottom. I would use those two triangles on the left and on the right to find the two lengths and add them together, and I would have my base. Let's call the one on the left, which is my adjacent side, let's call it X. And I will call the section on the right triangle, the blue triangle, as Y, and I'll leave the labeling the way it is. So let's look on the left side and solve for X. If I want that adjacent side, I would use adjacent over hypotenuse. The cosine of 40 degrees is x over 15. And I would solve for x that way. 15 times cos 40. And x is approximately 11.5. On the right side, we can get the other section of that base by using the blue triangle, and I will use cos. You could use cos or tan, doesn't matter. Cos of 60 degrees is adjacent over hypotenuse, which is the y value over the 11.13. Y is approximately 11.13 cos 60, and we get about 5.6. So the length of my side BC is the two together, 11.5 and the 5.6, which is about 17.1. So we found all the missing pieces. Little less rounding, I suppose. This is the same triangle with all the answers imposed. And we're just going to show you that the sine law works. Sine law is sine A over A, which equals sine B over B, equals sine C over C. Trigonometry in triangles is all about opposites. So when we are talking about sine A over A, we're talking about angle A over little a, which is across the triangle. Angle B over little b, and angle C, sine of angle C over little c. If we set up the triangle like that with opposites, there's the sine law. You can use the sine law all upside down as well if you wish, if that makes it easier for some calculations. Let's plug our numbers in and see if it's holding true for this triangle. Is it true that sine of 80 degrees divided by 17.06 is equal to sine of 40 degrees over 11.13 and sine of 60 degrees over 15? Well, if we type it into our calculator, for the first one I have decimal 0.577 and a whole bunch more. And for the middle one, sine 40 divided by 11.13, I have decimal 0.577. A couple more decimal places, just slightly different, so very close to being equal. Sine of 60 divided by 15 is right in the middle of the two, but to 4 decimal places they are identical. So for the rounding that we did here and here, the sine law is the same for all three. We must have done our work correctly on the front. Sine A over A equals sine B over B equals sine C over C, and we have it on the cheat sheet at the front of the room. Let's do one where we're solving for side A. So I'm going to label my sides. I have angle A across from little a, angle C across from little c, and angle B across from little b. My sine law happen to have the same letters, A, B, and C, so I'm just going to write it down and then we'll fill in what we know. Angle A, don't know. Little side A, don't know. Sine B is 62 degrees over little side B is 15. Angle C, don't know. Little side C is 13. So my actual goal is to get side A, but I don't have enough information to work on that ratio. So I'm going to look at these two, solve for angle C, and then I'll be able to work on angle A and side A. So to find angle C, I want to get sine C by itself. I'm going to multiply both sides by 13. So what I'm going to type into my calculator is 13 times sine 62 divided by 15, and I will get a decimal for sine C. I have positive decimal 7652. Do you expect angle C to be acute or obtuse? So to find angle C, we're going to inverse sine both sides of the equation. And what I would type into my calculator is second function sine of 0.7652, 49.9 degrees. C is about 50 degrees. So if I have 62 degrees and now 50 degrees, then really I know my angle A because all triangles add up to 180. So angle A is 180. Subtract the 50, subtract the 62. And I would get 68 degrees. So now I have 68. I have a 50. More information in my sine law will allow me to solve for side A. So I am going to use sine of 68 over A equals sine 62 over 15. And I can solve for A. Now if you have a variable in the bottom, it can be a little tricky. We want to get A to the top and isolated, so the first thing I would do is, you would call it cross multiply. Multiply both sides by A and by 15, so 15 times sine 68 equals A times sine 62. Now I don't have any denominators to worry about. I want to get A by itself. So on the right side, both sides, I'm going to divide by sine 62. So my new left side would become 15 times sine 68 divided by sine 62, and we will get an approximate value for A, about 15.8. For the second one, we're going to find the height. So this time we're kind of going backwards from the very first slide. We have a triangle that is not a right angle triangle, and we'll use a sine law on that in order to find the height. So drawing, what I'm actually looking for is that height, but I don't have any lengths in the right angle triangle on the left or in the right angle triangle on the right. It would be false to just divvy that 2.9 in half because it's not exactly in the middle. So we have to find lengths on either AC or AB that we could use in one of those two right angle triangles to find the height. So I'm going to set up my sine law with the triangle ABC. Okay, in the triangle ABC, I have sine A over 2.9 equals sine 5.9 degrees over little b, or AC, is the same, equals sine 10.3 degrees over little c, or AB. It looks like I don't have enough information to solve any ratio here, but if I know two of the angles, I actually know the third. So if I know 5.9 degrees and 10.3 degrees, I can find angle A. Angle A is 180 minus the 10.3 minus the 5.9, and we are left with 163.8. So now, if I replace that, I have enough information. One of my ratios is complete. I can solve for either B or C. Well, just because they're side by side and a little easier to read, I'm going to solve that ratio for side B. Okay, I'm going to rewrite it so we can read it. Sine 163.8 over 2.9 equals sine of 5.9 over B. To solve for B, again, the variable's in the bottom. We want to get it by itself, so we're going to multiply both sides by B. So the left becomes B times sine 163.8, and the right becomes 2.9 times sine 5.9. One more step before we touch our calculators. We're going to divide both sides by sine of 163.8. Have in mind what a reasonable answer for B would be. If the very large angle is across from a side of 2.9, what would a reasonable length for our side B be? All right, let's type. I got about 1.07, which would certainly seem reasonable with the diagram that we've been given. But that wasn't the end goal. The end goal was to find the height. So if I have found little side B, I'm going to replace it with 1.07. I can use the right angle on the side, the right side, sorry, to find the height. I have an angle of elevation of 10.3 degrees, a hypotenuse of 1.07, and I want to find the opposite side. So I'm going to label my sides. I'm using this triangle that's a right angle triangle where I have the hypotenuse and want the opposite side. Don't care about the adjacent side. So opposite over hypotenuse is sine. So to solve for the height, I'm going to use sine of 10.3 equals opposite over hypotenuse is little h over 1.07. To get the height, and that was a rounded decimal, so I'll put approximately equal to. I'm going to multiply both sides by 1.07, and I will have a height 0.19. So some to try. I know you've used them before, but page 17, 1 to 4, and 10 to 12.